Do you remember learning to ride a bike? I remember when I learned, it was like a whole new world where I could ride to the park or hang out with my brother and the other big kids. It wasn't quite the same though because I was on training wheels. Training wheels helped me to stay up on a bike because my weight could move from side to side and not fall over. Except for one time that I was riding my bike and I heard my brother's friend shout, "Your training wheels!" And I looked down and saw that they had fallen off, and I didn't fall over until I noticed this, and then I fell over. This bike has training wheels. There are two wheels on either side of the back wheel of the bike that help keep it upright even when you're not moving. This diagram shows what a bike looks like without training wheels. It can fall from either side. Add some training wheels, and now you have two more points of contact with the ground that can keep you up. When training toddlers to ride a bike, this new design has been popular lately. What it does is it takes away the pedals and the training wheels altogether. The toddler uses his or her own feet to keep them stable. That way, they learn the balance it takes for a bike, and it's easier for them to transition from a training bike up into a traditional bike without ever having to use training wheels. Bikes are inherently stable. That means that with a little bit of speed, a bike can pretty much stay upright on its own. Let's take a look at a diagram that helps explain this. Each bike is designed with these components. The important feature to keep it upright is the design of the front fork on the front wheel. Since it turns up, it creates this offset, and the center of this wheel ends up being behind the original axis. This distance is called the trail of the bike. You'll notice if I push the bike along in a forward direction, it pretty much stays upright. But if I try to go in a backwards direction, it almost immediately falls over. You can't do it. Here's an equation showing how the trail of the bike keeps it upright using the offset from center on the wheel and the angles of the fork. This diagram shows the lean of a bike as it turns using friction, the normal force, the length of the tire to the center of gravity, and the angle of the turn as they relate to centripetal acceleration. This is what happens when you turn on a bike. Bikes are inherently stable. That's how he's able to ride with no hands. Let's talk safety. Let's talk safety. The plastic shell of my helmet is designed to crack upon impact. The energy is then transferred through the rest of the helmet through sound and heat to the foam core here. This foam liner will compress slightly, thus slowing down my impact and bringing my head to a much safer stop. Let's ask Newton about this concept. Newton's second law is essentially force equals mass times acceleration. If we take a different derivation of this equation, we see that the sum of the forces equals mass times velocity final minus mass times velocity initial all over the change in time. With a bigger change in time, the sum of the forces will be much smaller than if there is a very short change in time, which basically means that you're coming to an instant stop. Next time you find yourself on a bike, keep in mind these physics concepts and how they make riding a bike even easier. Riding a bike is awesome! Don't forget your helmet!